Assalamu alaikum. Today we're going to talk about quadratic inequality. We are going to learn how to solve solve quadratic inequality using discriminant and the leading coefficient of a. So this is what we are going to learn today. So the concept of the discriminant and leading coefficient a. The idea behind this method is this method involves reading the quadratic graph, and those two tools, which is the discriminant and the coefficient, will help you read the graph and solve the quadratic inequality. So let me write down this. So this method involves reading the graph, the quadratic graph. All right. How it work? How how does it work? All right, first thing what you do when they give you the quadratic inequality to solve. So first what you do, you find the discriminant of that quadratic. It is uh, leading the sign of you conclude the solution and you are going to cases. So there are three cases. One, okay, discriminant. So when discriminant is negative. So I want you to see it this way. So when the discriminant is negative, always look at the graph right away. So how the graph look like when the discriminant is negative? So we have two cases here. If the discriminant is negative, so the graph will be one of those case. Either if the leading coefficient is positive, the graph will be somewhere above the x-axis. If A is negative, so the graph should be below the x-axis. What this What this tell me? Tell me that the quadratic is greater than 0. That means ax squared plus bx plus c is greater than 0 for every x. You see, for every x I pick here, you see it's still above. That means this is always positive. And here for every x, ax squared plus bx plus c, it's below the x-axis. That means is less than 0. Which means if you got one of those two inequality, you end up having all remember. So if my inequality was ax squared plus bx plus c is greater than 0, or ax squared plus bx plus c is greater or equal than 0. If we got one of these and a is positive and the discriminant is less than 0, the solution should be all real number. And the same thing here. So if my discriminant is negative and a is negative, and you get one of those two equation, bx plus c is less than 0, or ax squared plus bx plus c is less or equal than 0, because both of them still give you the solution all real number. But if I got the opposite, that means if I got ax squared plus bx plus c, for that case is less than 0, or ax squared plus bx plus c, this means is nothing below. You see, there is no x above the solution. A x squared plus bx plus c x squared. They ask me here, does mean if I have s is a quadratic above the x-axis, and is it impossible? Why? It must be below the graph. That means there's nothing above the x-axis. So that's mean here again. So where to equal 0, which means I have one x intercept. That means the graph here, the graph has one x intercept, and it's x equal minus b over 2a. So here again, the graph, it's look different based on a again. If a is positive, so as you see here, always when we have a is positive, is face up. I remember a positive from the lesson of the graph is concave, that means it's gonna face up. A negative face down. So when a is negative, the graph will look like this. Somewhere here it's gonna touch the x-axis at once, and it's gonna go up. So this is how it looks like. That means everywhere is positive and it's equal 0 only at that point. That's it. Everywhere is above 0. And if it's negative, so it's going to be like this, and it's touch the graph once and go down. That means it's equal 0 once, but the rest is always negative. So which means here we have different cases. That means here we can have an inequality that has only one answer, and we can have an inequality that has infinity of answer, and we have an inequality that has no answer. So we have the three cases here. So let's do the first case when we have infinite of answers. So for example, if they give me this quadratic ax squared plus bx plus c is greater or equal than 0, what does mean? What does it mean? Does that mean the quadratic is can be 0 and it's positive? That means it can be 0 and it's positive. That means all real number will work for me here. So that means here my solution here will be all real number. So, and the same thing for negative. So if I do negative, I have ax squared plus bx plus c, and it's less or equal than 0. This means that the quadratic is negative and it can be 0. And this means the graph will touch the x-axis, which means that all the x will work for me in that case. This means again here is minus infinity to infinity. Now, suppose they give me ax squared plus bx plus c is greater than 0. What does it mean? Does not touch 0. That means this expression never can be 0. So it works for every number except on that one. That means that one is not going to be included in my solution. So my solution will be defined as minus infinite minus b over 2a union minus b over 2a to infinite. So I include all the number. So you see it's like this. Look, if I do this one in terms of graph, it's going to look like this. You see, it's going to look like this. Let me think of this. So it's going to be like this somewhere. This is my b over a. You see, I don't include that one, but I include anything because all of them they give me a quadratic. So that's the idea. Because of this, you see, and the same thing here. So square plus bx plus c is less than that one because I don't need to. So everything works except which is that number minus b over 2a. Same thing as this one minus b over 2a is when positive. So here, suppose this is positive, but this plus c is less than equal to this as 0. So I think negative, but it's in that case I have only one solution here is when s and the same thing here. So if I have ax squared plus bx plus c, this never can be positive, but it can be equal 0. You see, when it is when we have x squared plus c is less than 0, so that's above, but for something less than 0, so here solution. And the same thing here, if I bx plus c, which is greater than that, for anything, any x that make the quadratic above the x-axis here. So this is for the second case. The case C. So in that case, we have two intercepts. So there are two x-intercepts. So the graph has two x-intercepts. So let's suppose we have one of them is greater than the other. So assume that C1 is greater than C2. So the two x-intercept is C1 equal minus B minus square root of the discriminant over 2a, and C2 will be minus b plus square root of the discriminant over twice a. So assume that C1 is greater than C2, because when you find out the x-intercept, you must have one greater than the other. So that's the idea. Now, so if the graph of this type, how it look like? If a is positive, so the graph will look like this somewhere here. We have two x-intercept. This is just a random graph. If a is negative, what does it mean? It does mean the graph look like this. And we have two x-intercept here. And this, how we can read this, which means that certain x's make this expression negative, and there are certain x's make the expression positive. You see, here the graph is above. That means the expression, which is the correct expression, is positive. Between the two x-intercepts, you see the graph is below, which means the expression is negative. You see, here the expression is negative, and here the expression here is positive because it's above the x-axis. For that case here, you see, the graph here is above. That means this is positive. That means between the x-intercept, the graph is above the x-axis. That means positive. And below, you see, here below, it's negative, which means this side of the x-axis. And this side make the graph negative. That means the expression make the expression negative. That means here the expression is negative. And this is how you should select your solution. So for the case, if they give me, for example, these equations, ax squared plus bx plus c is greater or equal than 0, you see, I include those x-intercept because this is greater or equal to 0. That means those make the expression equal 0. And I take those side, which mean from minus infinite to the c1. This is c1, this is c2. So this is c1, this is c2. From minus infinite to c1, and from c2 till infinite, because this is where the graph is negative. If they ask me less than 0, so I'm going to just pick from c1 to c2 because this is where the expression is negative. So here we have the solution is minus infinity to c1, which is I include, union c2 to infinite. So if they ask me, for example, ax squared plus bx plus c is strictly greater than 0, I don't include minus Now, if they ask me if ax squared plus bx, just speak, my solution be c1. If they ask me for ax squared plus bx plus c equals sign, so my solution will have graph it. Just look at the term and the leading coefficient is concave up has two external tails of the graph. The two tails, those are the two tails of the graph are above. Those side is greater than 0 and in the graph. And for that case here, if they give x plus c is less or equal to negative, so going to be the same thing as this solution. So is minus in to do infinite. But if that expression to divide to make this expression equal 0, but I pick only the negative part, set of solution will be minus infinite to C1 union C2 to infinite. Now if I have the plus C only be intercept where the graph is above, this is where the x is passed. So that will be C1. This is strictly greater bracket. You may see for any quadratic inequality. So let's do example. I wanna solve for example, square minus 2x plus 3. So here what I need to do first, move everything in one side and keep the other side empty. So here, because we discuss only this type of equations, ax squared plus bx plus c is greater than 0. So that's mean we need to make it look like this expression. So move everything in one side. So this is what you should do first. So to do so, what I need to do, I need to minus 2x minus 3 both sides. So my equation will become, my inequality will become 2x squared minus 5x minus 3 is greater than 0. Okay, now I need to find out my discriminant. So this is my first thing I do, which is b squared minus 4 times ac, which is minus 5 squared minus 4 times 2 times minus 3, which is 25 plus 24, which is 49, and this is perfect square. So I know now it's positive. This is positive. This way I have two x-intercepts. So my graph is going to look like this. It's going to look like this. This is just a random graph. This is greater. That means I don't include those two because it cannot be 0. So let me find out those two values. So we know that C1 is minus B, which is minus B minus square root of the discriminant over twice A. So which is the same thing as minus 5. So it's going to be 5 minus 7 over 4, which is minus 2 over 4, which is minus half. And C2 is minus B plus square root of the discriminant over twice A, which is 5 plus 7 over 4, which is 12 over 4, which is 3. So I know that this is my, so if I see what you call it, C2 to minus half infinite, and this will be my in the graph. it's above on that side. You can see it. So I want to solve so here just this for d, which is going to be somewhere below the x-axis. So you see here a is negative. This expression is negative. That means my solution is work for every x is minus infinity to infinite. So for example, I want to solve for uh, x squared plus 2x plus 7 is less than equal to 0, for example. So here again, I'm going to find my discriminant, b squared minus 4ac, which is 2 squared minus 4 times 1 times 7, which is 4 minus 28, which is minus 24. So the discriminant is negative, and we have a equal 1 greater than 0, which means the graph is going to be above the x-axis. Here they ask me the quadratic should be less than 0. It's impossible because there is no such input that gives me a negative output. That means this never can be negative, so which means that I have no solution here. Another example. So if I want to solve, for example, 4x squared plus 3x minus 1 is greater or equal than 0. So my discriminant here, b squared minus 4 times ac is 3 squared minus 4 times 4 minus 1. So it's going to be 9 plus 16, which is 25, which is 5 squared. Now I know that a is equal 4 is greater than 0, which means that I have the graph is going to look like this. So I have two x-intercept and they are included. So I will include those two, and they want this expression to be above the x-axis. So here, so those x's make the expression above the x-axis. So here I need to find out those C1, C2, those x-intercepts. So I know that C1 will be minus b minus square root of the discriminant over twice a, which is minus 3 minus 5 over 8, which is minus 8 over 8, which is minus 1. And C2 will be minus b plus square root of the discriminant over twice a, which is minus 3 plus 5 over 8. So here's going to be 2 over 8, which is 1, 4. So now my solution is everything outside here. So it's going to be minus infinite to minus 1. I include because this is can be 0. Union 1/4 to infinite. So this is my solution for that type of equations. So let's solve this. For example, I have 2x squared minus 8x plus 8 is less or equal than 0. So my discriminant here is minus 8 squared minus 4 times 2 times uh, 8, which is 64 minus 64 equals 0. This tells me that the graph has only one x-intercept, so a equal to is positive, and the graph will look like this. Because it's positive, it's going to touch the x-axis in one point. Let's assume that this is the only way where it can be 0. Now what they want the expression to be negative. So when the expression is negative, this cannot be negative. Why? Because when d is equal 0, that means a perfect square. I should check a is positive. That means this expression can be always positive, is above 0, but it can be 0 once at x equal minus b over 2a. This is where the expression can be 0, which is minus 8 over 2 times 2. So it's going to be 8 over 4, which is 2. So that's the only point where the graph can be 0. So this cannot be negative, but it can be 0. So you see, this is how it works. This can never be negative because of those information. A is positive and d is equal 0, but it can be equal to 0. So the only solution I have for this one is when this expression equals 0. So my only solution is this, because this is where the expression, and this can never be negative. Right, let's do another one. So let's suppose we have, I will use the same idea. So 2x squared minus 8x plus 8, this is less than 0. You see, it's the same question, but I just change the sign and make it strictly less. In that case, I will have no solution because we find out that the discriminant here is 64 minus 64, which is 0. And we know that a is equal to is positive. So this means the graph touch the x-axis only at one x-intercept, which is here, but they want this expression less than 0. That means they want to find out when this can be strictly less than 0, which is impossible because this is always above the x-axis. That means it's always positive. So there's nothing here that make this expression negative. So my solution here will be empty. That means there is no solution. So I don't know if I can add another one. Okay, let's add the last one, last example. So I want to solve for example, 3x squared plus 12x plus 12 greater than 0. So here my discriminant is b squared minus 4ac. So here it's 12 squared minus 4 times 3 times 12, which is 144 minus 144, 0. Here a equal 3 greater than 0. So I know that the graph will look like this because it's a perfect square and it has only one x-intercept. So here they want the expression to be positive and or equal to 0. That means this match my expression, so it's positive and it can be 0. So that means all the x will work for me. So my solution is minus infinity to infinite, and this will be your answer. So I hope you got the idea behind how to solve quadratic inequality using discriminant and the leading coefficient a. So if you have any comments about the way I explain or way I teach, so please do so. It will help me improve my way of teaching. And thank you for watching the video, and Assalamu alaikum.